Hi friend, myself Sanju. I'm making video on Thevenin's theorem, which having a voltage source of V, let us V1, and a resistance of R1, and another resistance is R2, some resistance which is taken as RL. This is the resistance. This circuit which will be simplified as single equivalent voltage source as VTH with single equivalent resistance RTH along with the load resistance R. Means this is the not only one voltage source here, it may be two voltage sources with current source, then other sources are also there that are replaced with single equivalent voltage source VTH with series resistance of RTH. After the simplification, so we can obtain the current through the load resistance RL by using the known formula, that is IL is equals to, this is a series circuit, the voltage is V Thevenin's and the resistance RTH plus RL. These two are in series, means the resistance are additive in series connection. So then IL is equals to VTH by RTH plus RL. For suppose we have to find out the voltage VL. VL is equals to, we know that IL into RL. You can substitute this IL here, you can get the voltage. If the power across that element PL, that is VL into IL. So already we have VL and IL. Substitute here, you get this power PL. And also it can be known as IL square into R. Or that also equals to VL square by R. In this way we have to find out. So for observe the statement, in a linear bilateral circuit consisting of number of voltage sources and current resistances, these are replaced with single equivalent voltage source VTH with single equivalent series resistance RTH along with RL. In this, for solving, we obtain three steps. Step one is to find equivalent voltage VTH. To find this equivalent voltage VTH in a given circuit, remove the load resistance RL, means where we have to find out the current or voltage or power, that resistance have to be removed. Then after removal, the equivalent circuit can be written as, this is V1, this is given resistance R1 or 2, R1 or 2. Here the load resistance removed, then this marked this terminal as A and B. Here it becomes open circuit. Whatever the voltage available at these open circuit terminals is VOC, or they are also called as Thevenin's. VTH is nothing but the voltage across this R2 resistance. That voltage is called Thevenin's. For every circuit we have to do in this way only. Just remove the load resistance RL between the terminals. That voltage is called as open circuit voltage. The voltage between terminals A and B is called open circuit voltage. Next, step 2. What we have to do in step 2? In step 2, to find RTH, to find RTH, R Thevenin's, means in a circuit, what are the sources we have? If the current sources are there, just short circuit it. If there any internal resistance, replace with that resistance. Any internal resistance is given, replace with that internal resistance. If voltage So sorry, this is voltage sources, not current sources, voltage. If current sources are there, then replace with open circuit. If any internal resistance is there, replace with that internal resistance. Voltage source with short circuit, current source with open circuit. That is fine. And only in given circuit only we have one voltage source, that is V1. That make sure that will be short circuit, means it will be 0. Means just short circuit the terminal, remove the voltage V1, then redraw the circuit as it easily. This is R1, R2. Here we get equivalent resistance between terminals A and B, that is RTH. That is RTH, the resistance seen from these terminals A and B. If current will flowing here, these two terminals are parallel. R1 is parallel to R2. Means the equivalent resistance is R1 is parallel to R2. That is RTH. It can be written as R1 into R2 by R1 plus R2. This is the equivalent resistance. Now step 3. What we would do in step 3? In step 3 we have to draw the equivalent circuit. Equivalent circuit. We draw the equivalent circuit. How to draw the equivalent circuit means, firstly we find out Thevenin's. Write the value here are Thevenin's, whatever you get in step 2, substitute here, and firstly you remove the load resistance RL, add the load resistance RL. Now the current is IL here. Already in starting we note down the formulas for IL, VL, PL. In this way we can find out the values of current, power, voltage by using the Thevenin's theorem. Now friends, thank you for watching my video. If you are like the video, please like it, share the video. So in next video I have to solve some problems which are given in UPSC IAS exams. Okay, in this topic we can discuss some problems, then you can clearly understanding how to solve and how to apply this Thevenin's theorem for solving the circuits. Thank you friends, thank you very much.